Good morning. Collision properties, collision diameter. When two gas molecules approach one another, they cannot come closer beyond a certain distance. The shortest distance between the center of two molecules taking first collision is called collision diameter and represented by sigma. In case of pure gas, collision diameter. Sigma equal to sigma 1 plus sigma 2 over 2, where sigma and sigma 2 are the molecular diameter of first and second gaseous molecules. Collision frequency, it is defined as the number of molecular collision taking place per second per unit volume. It is defined as the number of molecular collision taking place per second per unit volume, and represented by Z11, number of molecular collision taking place per second per unit volume. Collision number, number of collision made by molecule with other molecule in 1 second. Okay, derivation. Let us consider that all molecules except one molecule are at rest in a particular gaseous system. Distance traveled by molecule A in 1 second, velocity multiplied time v meter per second, 1 second v meter after colliding. Figure collision across, collision cross section pi sigma squared. Two molecules, distance between diameter sigma, this is the v meter. Volume swept out by a molecule pi sigma square b. If number of molecules in volume n, the number of molecules pi sigma b equal to pi sigma square bn. The number of collision made by the molecule A in 1 second pi sigma square bn. If two molecules with the velocity v1 and v2 collide at angle theta, then at the relative speed Vr is given by the relation Vr equal to root under v1 square plus 2v1 v2 cos theta plus v2 square. Since all angles from 0 degree Celsius to 180 degree Celsius are possible, the average angle of 90 degree is accepted and v1 equal to v2 is assumed. So Vr equal to root over v1 square plus 2v1 v2 cos 90 plus v1 square. So root under 2v1 square plus 2v1 v2 0. So root over 2v1. The number of collisions made by a molecule will be greater than the expressed by equation 3, and the number of collisions made by a molecule A in 1 second is Z1 equal to root over 2 pi sigma square V1. The number of collisions made by the N molecules in 1 second, root over 2 pi sigma square Vn squared. For bimolecular collisions, total number of collisions per second per unit volume, root over 2 pi sigma square Vn square over 2. So that Z11 equal to half. pi sigma square. Okay, this is the collision frequency for identical molecules of A and A types. In case of mixture of two gases A and B, the number of binary collisions per unit volume per unit time, let binary collisions between A and B molecule, and also let N1 and N2 are the number of A and B molecules per unit volume. The collision frequency of A molecules Z1 equal to okay, Z1 equal to 1 over root 2 pi sigma square B1 N square. The collision frequency B becomes Z2 similarly. uh, 1 over root 2 pi sigma square B anti square. Let the diameter d and the molecular weight m for A and B molecules from the equation 6. One over root 2 pi sigma square B n1 plus n2 squared. The collision frequency involving A and B only. Z1 to 1 over root 2 pi sigma square B 2 n1 n2. Okay, so Z1 to root 2 pi sigma square B n1 n2. Sigma and sigma 2 are the diameters of A and B, and the m1 m2 are the molecular masses of A and B. So sigma equal to sigma 1 plus sigma 2 half, mu equal to m1 m2 over m1 plus m2. Mu reduced mass, so average velocity root under at RT 2 pi mu. Substituting value of B and sigma in equation 10, we can write Z1 1 2 equal to root under 2 pi sigma 1 sigma 2 plus over half squared at RT over 2 pi mu n1 n2. Again, we can write Z12 equal to N1, N2, sigma 1, sigma 2 half root under 8 pi RT over mu. Okay, the collision frequency involving A and B only. Z12, Z minus Z1 minus Z2, Z12, 1 over root 2 sigma pi sigma square B N1 plus N2 squared minus 1 over root 2 pi sigma square B N1 squared minus 1 over root 2 pi sigma B N2 squared. So Z12 equal to 1 over root 2 pi sigma square B N1 N plus N2 square minus N1 square minus N2 square. Z12 equal to 1 over root 2 pi sigma square B N1 square plus N2 square plus 2 N1 N2 minus N1 square minus N2 squared. Z12 equal to 1 over root 2 pi sigma square B 2 N1 N2 Z12 root under 2 pi sigma square B N1 N2. Let sigma 1 and sigma 2 are the diameters of A and B, and M1 M2 are the molecular masses of A and B molecules. So sigma equal to sigma 1 plus sigma 2 half, mu equal to M1 M2 over M1 M2, M1 plus M2. So E mu reduce mass, average velocity B equal to root under 8 RT over 2 pi mu. Substituting the value of B and sigma in equation 10, Z12 equal to root under 2 pi sigma 1 sigma 2 half square root over 8 RT over 2 pi mu N1 N2. Z12 equal to N1 N2 sigma 1 plus sigma 2 half square root over 8 pi RT mu. Z12 equal to N1 N2 sigma 1 sigma 2 square root over pi RT over 2 mu. If value of mu is put in the question 11 and 12, Z12 equal to N1 N2 sigma 1 plus sigma 2 half root over 8 RT M1 M2 over M1 plus M2. Z12 equal to N1 N2 sigma 1 plus sigma 2 half root over 8 RT M1 M2 over M1 M2. So Z12 equal to N1 N2 sigma 1 plus sigma 2 root over pi RT over 2 M1 M2 M1 plus M2. We can write Z12 equal to N1 N2 sigma 1 plus sigma 2 square. If value of mu is put in equation 11 and 12, root under 8 RT 8 pi RT over M1 M2 over M1 plus M2. N1 N2 sigma 1 plus sigma 2